All right, let's start taking a look at the last section in Chapter 1, Graphs of Functions. Okay, circles. So there's a standard form for an equation of a circle. We'll learn about that, and we'll learn how to graph and work with that equation. The first thing we really want to address, though, is what is a circle? A lot of people have this intuitive notion of what a circle is, but in math, we want to be really, really precise. So, for example, students might say, oh, a circle has to be round. And then I'd be like, well, what about this? It's kind of round. Is it a circle? And they say, oh, no, it has to be like, equally round. Well, what does that mean? And then almost always they'll come back at me with something involving the word circle. Well, it has to be circular. And I'll be like, well, that's exactly what we need to figure out. So we need a good definition, okay? So here's the math definition. A circle, it's a set of points that have the same distance from another point, which is called the center. The distance is called the radius. The given point is called the center. So here's the center of the circle, some h comma k. Here's a point that's distance r. Hey, here's a point the same distance away. Here's a point the same distance away. Here's a point the same distance away. All the points the same distance away form a circle of radius r with center hk. What is a circle in math? A circle is all points whose distance to a given center is the same, and that distance is called the radius. Okay. Now, the standard form of a circle of radius r and center hk is given right here. Why? Well, it's really just the distance formula. If xy is our unknown point, and hk is our known center, and r is the distance, if I set up the distance formula, it says the distance is the square root of x2 minus x1. I'm just repeating it from like the first section we did here, plus y2 minus y1 squared. Okay, what's x2, y2? Let's call that x comma y. What's x1, y1? Let's call that h comma k. What's the distance? It's r. And let's square both sides to get rid of this square root at the expense of having a squared here, and you end up exactly here. We would have r squared is equal to the square root of x minus, no square root. We squared both sides to get rid of it. X minus h squared plus y minus k squared. Okay. So here's our general standard form for the equation of a circle. Notice if the center is 0, 0, then instead of x minus h squared, if h is 0, you can just call that x squared. And instead of y minus k squared, if k is 0, you can just call it y squared. So if the center is the origin, it looks a little nicer. The unit circle, and this is going to be really important for us right around midterm and then for the rest of the semester after that. If the radius is 1 and the center is the origin, this together is called the unit circle. So since the center is the origin, this side looks pretty nice. And since the radius is 1, 1 squared is just 1, that side is also pretty straightforward. The unit circle is all points whose distance from the origin is 1. The center is the origin, the distance is 1, okay, radius is 1, center, origin, unit circle. It's, of all the circles that are out there, it's like the most standard. Its center is right at the middle at the origin, and its radius is pretty simple, it's just 1. So, can we write the standard form of the equation of a circle with radius 6 and center -2, 5? So the radius is 6, h is -2, k is 5, and I just go back to that r squared equals x minus h squared plus y minus k, standard form for a circle. There it is. What was h? It was -2. What was k? It was 5. What was r? It was 6. And there you have it. X minus -2 just becomes x plus 2. You could expand this out if you wanted to, but then it wouldn't be in the standard form anymore. So, hooray, we're done. Can I graph a circle, given only the equation? Well, it is in standard form, and that's going to tell us some stuff. So, does this look like x minus h squared plus y minus k squared equals r squared. Yes, it tells us that h is -1, k is +1, and r is 3. So a lot of people get that this looks like x minus -1, and this just looks like y minus 1, but then they'd make a mistake of saying the radius is 9. In standard form, remember that that other side is the radius squared. So if r squared is 9, then the radius is 3. So can I graph that? Well, we determined the center was hk, or -1, 1, and the radius is 3. So what are all points distance 3 from -1, 1? A couple of them are easy to plot. If the distance is 3 and I move straight up, from -1, 1, if I move straight up 3, I just get a height of 4, but if I move straight down, I just get a height of -2. If I move straight to the right, I get an x-coordinate of 2. If I move straight to the left, I get an x-coordinate of -4. So some points on the circle are easy to plot, but that's pretty much it. Otherwise, it's just this whole circle. Pardon me. Can we find the intercepts of a circle? Sure, it's the same as it's been. To find the x-intercepts, let y equal 0 and see what happens. So in this particular example, if I let y be 0, this term here overall doesn't go away, but it does get a little easier. What's 0 minus 1? -1. -1 squared, +1. Subtract that over 8. Okay, so we have x plus 1 squared equals 8, which means x plus 1 is plus or minus root 8. Don't forget about this plus or minus. Root 8 simplifies as the square root of 2 times 4, otherwise known as the square root of 4 times the square root of 2, and root 4 is 2. So that's where that 2 is coming from. Root 8 is just 2 root 2. X plus 1 is plus or minus 2 root 2. Subtract that over, and here is my values of x. -1 plus or minus 2 root 2. So it has 2 x-intercepts. -1 minus 2 root 2, which is about -3.83, but honestly, if you just write it like this, that's more accurate. When it comes down to plotting it, it is convenient to have a decimal approximation, but if you're just writing it like without drawing any graphs, -1 minus 2 root 2 is totally fine. And -1 plus 2 root 2, which is approximately 1.83. To find the y-intercepts, we do the same thing. Let x equal 0. So over here, we just plug in x equals 0. Okay, what's 0 plus 1? It's 1. Squared is 1. Subtract that over. I get that 8 again. So again, we end up with plus or minus 2 root 2. And then I move the 1 over, and we get 1 plus or minus 2 root 2, which are pretty much the same things. So we found some intercepts. Good. Here, it's the same circle we've been looking at. Here is its center. Here's its radius. We found these intercepts and these intercepts right there. Okay. Now, we had our standard form of x minus h squared plus y minus k squared equals r squared. If you expand all this out, you get x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared equals r squared. How did I get all this? If you just FOIL out x minus h times x minus h, you get x times x, x squared, minus h times x, but then you get another minus h times x, and then finally you get a plus h squared. So there is this, it's x squared minus 2hx plus h squared. When you do the same thing to the y minus k term, you get these things right here, and then the right-hand side is still just r squared. Point being, I have some x squareds, some y squareds, some x's, some y's, and then some other things that are just numbers. And if you collect terms like that, you get an x squared, a y squared, some x's, some y's, and a bunch of numbers added together, which is just another number. This is called the general form of the equation of a circle. So here is something that looks like it's in this general form. We've got some x squareds, we have a y squared, we have some x's, we have some y's, and we have a number. Can I figure out what the center is and what the radius is? Yeah, sure. Group the terms that have x's and group the terms that have y's and put everything else on the other side. So I've grouped the terms that have x's, I've grouped the terms that have y's, and I move that 4 over. Now what we have to do is something called completing the square. This is a technique you should be familiar with. So if I complete the square on x squared minus 6x, I take that minus 6 and divide it by 2, and I get minus 3. And then I square it, and I get 9. But I can't just add 9 to this side. That would change it. What I can do is I can also add 9 to this. Now I've added 9 to both sides, which has preserved the fact that it's the same thing I started with. For this term here, what's 4 over 2? It's 2. If I square it, we get 4. But if I add it to the left, I'd better also add it to the right. Because now, this simplifies as just x minus 3 squared, and this is just y plus 2 squared. And now on the right-hand side, we have a negative 4 plus 9 plus 4, which simplifies just to 9. And now we can recognize it pretty directly as having center 3, negative 2, with radius root 9, aka 3. Okay, so can we graph it? Sure. We found its center, 3 minus 2. We found its radius, 3. So we just move up 3 units. If I move up 3 units and I started at y equals minus 2, I'm going to end at y equals 1. If I move down 3 units, I'm going to end at negative 5. If I move right 3 units and I started at x equals 3, I'm going to end at x equals 6. And if I start at x equals 3 and I move left 3 units, I'm going to end at x equals 0. And that's how we get these 4 points, and that helps us plot this circle here. Can we graph the equation x squared plus y squared equals 9? This is the last example I'll do, by the way, before splitting off into a new video. So this is got center 0, 0 and radius 3. And the point here is not to draw it by hand, which is pretty easy. It's can I make a computer do it and actually give me the correct picture? Because using your calculator or something, like Google Plotter or Desmos or any of those online tools, you really, 9 times out of 10, it's saying, what is y equal to? And then I can plot it. So we have to solve this for y. So we move the x squared over, take the square root, but remember it's plus or minus. So y is plus or minus root 9 minus x squared. That's going to give us this circle. If you made the mistake and you just had this, you forgot the plus or minus, then a plotting utility is just going to draw the top half of the circle, and it's going to be missing half the picture. Okay. However, most plotting utilities won't let you enter plus or minus something. So you have to do it twice. You have to graph it once with the plus and once with the minus, and ask it to plot it on the same screen. And then it'll draw it kind of like this. It seems like kind of an unpleasant workaround, and it's kind of a technological limitation. Some more recent things can understand plus or minus, or you could even just ask Google to plot this for you, and it'll just graph it. It's gotten quite smart. But TI calculators, for example, generally can't do it. The computer is not as smart as you are when it comes to this sort of thing. Okay. So that's it. That's all for circles.